Hello everyone, or as they say in Australia, g'day. I'm Andrew Timming. I'm the lecturer for this course, and this is my dog. So come on. We recently moved to Australia from Scotland, and I flew my dog all the way over here to be with me and my family. So, I have had a chance to review the discussion board for the activity for week 1, and this was a tricky activity, and I thought I would just spend a little bit of time going through the distinction between what is meant by descriptive statistics and inferential statistics, because there was some confusion based on the discussion. So I like to think of the distinction in these terms. Descriptive statistics is what we know, and inferential statistics is what we think we know based on what we know. Okay? So let me explain that a little more clearly. Descriptive statistics means that we've collected data and we understand the parameters of those data, and the parameters simply describe what we know. So we know, based on the data we've described, that the average is X, or that the most frequently occurring figure is Y, whatever. So descriptive statistics do exactly what they say they do. They describe the data. Inferential statistics go one step further. So with inferential statistics, what we do is we draw a sample, a randomly drawn sample, from a wider population, and then based on the results of that sample, we make generalizations to the wider population. In other words, we're making something of a quantum leap from the sample to the population. They're called inferential statistics because effectively what we're doing is we're estimating what these results would be if they were in the population. See, we don't have a lot of population data. A population might be all Australians. We don't have surveys that are administered to all Australians aside from perhaps a census. But if we were going to ask who would you like to be the next Prime Minister of Australia, it would be too expensive to ask every single Australian this question. So what we do is we take a sample, a representative sample of Australians, and ask them that question. And then based on the results of that sample, we make a generalization from the sample to the population. So there's always a degree of error or uncertainty when it comes to inferential statistics. We're inferring from the parameters of the sample what the results would be or could be in the wider population. So we know the sample, but we don't know the population, and so we use inferential statistics to make estimates about the population based on the sample. Okay? So the distinction here is, whereas a sample simply describes, that's descriptive statistics, when we make a generalization to the population, that's inferential statistics. Okay? So anytime you see terminology such as we estimate that, or we think that, or it is estimated, that's inferential statistics. We don't know for sure, but based on these data, we think with a certain degree of confidence that this is likely to be the case in the wider population. If you see a definitive statistic, see 1 in 4 or 25% or 35%, that's descriptive if it applies purely to the sample. Okay? So again, to round this discussion back up, the distinction here is that a descriptive statistic simply describes something, whereas an inferential statistic goes beyond the description and makes a generalization, or a quantum leap, if you will, from the sample to the population, right? So we're estimating, or we're inferring, or we're making a guess based on these data, okay? So I hope that that distinction is a bit clearer for you now, and with that, I will be signing off. But before I do that, I would like to remind everyone to please fill out the plagiarism declaration, because if you don't do that, you won't have access to the assessments. They won't appear on your Blackboard page. So please remember to do that. Right. Thank you very much. And this is me signing out, and I think my dog might want to sign out too. Sound, come on. Can you say goodbye? Oh.